So good afternoon, everyone. This is Rakesh Rao, Executive Editor of First Construction Council, welcoming you for today's virtual events, which focuses on the topic of smart tech for cement industry. This webinar is jointly organized by Indian Cement Review, Construction World, Infrastructure Today, and Equipment India. Today's event is supported by FL Smith Cement as presenting partner and ABV as the gold partner. Before we proceed, I will just brief how we will take these events of today forward. So after the presentations, there will be a panel discussion for 60 minutes, and then the forum will be open for the Q&A from the audience. Humble request to all the participants, keep yourself on mute during the presentation and also during the panel discussion. And if you have any questions during the course of the panel discussion, you can type in your questions in the chat box, or towards the end of the event, you can ask directly to the panelist. So with these few words, I will just start my presentation, basically introducing the First Construction Council and its activity, and then we will take the proceedings forward. Hope the screen is visible to everybody.
Yes.
Thank you.
Yes.
So the First Construction Council is an infrastructure think tank for the construction industry and is dedicated to promoting its causes and the needs. Council is a platform to promote the adoption of best practices and be the torchbearer for all policy initiatives that are needed for the welfare of the construction industry and its industry's unified voice. And the council is governed by a board of governors who are distinguished industry leaders, like you can see on the screen. DK Sen of Larsen & Toubro, Mr. Pradeep Singh of IDFC. And then we have Mr. Sanjay Seth of Griha Council. Then Mr. Sandeep Singh of Tata Hitachi MD. Then Mr. Subodh Dixit, who is former Executive Director of Sapoji Palanji. The members of the council benefit in more than one ways. This includes industry networking opportunities, knowing consumption trend, understanding the market conditions better, and access to growth opportunities. And how do members achieve all this? Through white papers and research reports released by the council, and through several events, webinars, conferences, and award ceremonies that we host every now and then. So recently, that is in last month, we had a metro rail conference in Bombay, which brought together industry leaders, policy makers, urban planners, and technology experts. Our next event is going to be this Cement Expo Forum 2025 on March 5th and 6th at Taj Krishna, Hyderabad, with the theme of growing profitably. The event will also witness a presentation of Indian Cement Review Awards to recognize the contribution of the industry in nation building. Cement Expo Forum will bring together industry leaders, professionals, and decision makers from across India's cement and construction sectors. We are expecting over 1,000 delegates representing a wide spectrum of the industry. The event is supported by the organizations such as BMTPC, Global Cement and Concrete Association, Government E-Marketplace, that is GEM of Government of India, and Cement Manufacturers Association. Indian Cement Review Conference will address critical topics such as impact of consolidation on the cement industry, sustainability initiatives and technologies for improving operational efficiency, and market dynamics and innovations amongst other. So on the screen, you could see the list of events that the First Construction Council is going to organize throughout the year. In case anybody is interested in joining First Construction Council or any of the events, please drop in a mail at contact@firstconstructioncouncils.com. Coming back to the today's topic of discussion, India is the second largest producer of cement in the world after China. As per the Economic Survey of India 2023-24, India's current annual installed capacity of the cement industry is about 622 million tons, with cement production of around 427 million tons in FY24. The industry is expected to add another 210 to 220 million tons in the next 5 to 6 years. In this growth boom, adoption of cutting-edge technology will be crucial for cement manufacturers to stay competitive and meet the environmental standards. So against this background, today's webinar will explore the transformative impact of adopting advanced manufacturing technologies on the Indian cement industry. Our guests for today's webinar will include Dr. Hemantkumar Aiyer, VP and Head R&D, Novoco Vesta Pop Limited. Dr. Raju Goyal, Executive President, Chief Technical and Sustainability Officer, Ultratech Cements Limited. Dr. Rizwan Sajan, Head Global Sales and Proposals, Process Control and Optimization, FL Smith Cement. Mr. Prasanajit Dutta, Director Operations, PS Digitech, HR India Private Limited. Mr. Raghu Voduka, Chief Digital Officer, JSW Cement. And Mr. Sachin Vaidya, Regional GM, Digital Process Industries, ABB. The session will be moderated by Dr. B Hegde, Professor, Jain College of Engineering and Technology, Hubli, and visiting professor, Pennsylvania State University, USA. We are grateful to have PL Smith Cement has presenting partner. Sorry, we are grateful to have PL Smith Cement as a presenting partner and ABP as a gold partner for this webinar. So with this, I would stop my presentation, and I would now request our first presentation from Dr. Rizwan of PL Smith Cement. Before he starts, let me introduce him to our audience. With over 26 years of extensive experience in the industrial automation, Dr. Rizwan is a dedicated and passionate leader committed to integrating automation technology with process domains to create value for his customers. He has hands-on experience in delivering automation solutions across diverse industries, including machinery, chemicals, power generation, food, cement, and mining. With this, over to you, Mr. Rizwan. You can start the PPT.
Yeah, thank you, Rakeshji. Thanks for the nice introduction. Let me share the screen. Is it visible?
Yeah.
Yeah. Okay. Yeah. Thank you, Rakeshji, for the nice introduction. And as we have the topic today, the digitalization and Industry 4.0, right? So it makes sense what we are talking about, and then what is that the advanced technologies can do to transform the cement industry, right? So coming from FL Smith Cement, having the process knowledge, right, it makes more efficient for us to develop the softwares which is more relevant for the cement industry. So for the agenda today, what I have is introduction to the 4.0, and then raw mix quality control. That is the key for a stable cement production. And then the process optimization, which is the hot topic in today's date. So how can we produce more with less resources like fuel and energy? And then the final, the last one, but not the least, that is remote optimization. That is the future of plant operations. This is how the control room has evolved, right? From 1960s to till today. We have seen that we had several signals, like for example, few signals to 16,000 signals today coming to the control room. So the as part of the digitalization process, as part of the automation and then the advanced technologies, right? How can we convert this so much of loaded information into useful information and then make them as useful insights to operator and also to the maintenance engineers and further to the department heads, right? It make more sense of using this data, which we have from several areas like energy and then the process and the production data. We need to streamline them and then make them useful information to the plant people, right? So that the plant can be produced with most efficient way of producing it. So what is that in us for in industry 4.0? We know that we need cost savings out of this industry 4.0. It's not just an implementation of some technologies, but what it can give and what can how the cement plant can benefit from this industry 4.0. So the most important factor is the cost saving, and then the quality must be improved, right? So how the technology can help to improve the quality part of it, and then how to increase the uptime of it, because in even one unplanned shutdown can take a lot of money from the plant, right? And then make us less efficient. So how to make more efficient, but I think by increasing the uptime. So the greater productivity, that is the most important thing, that how to increase the production with the less resources what we have today. And ultimate aim is to reduce the environmental footprint, right? And then this is how the transformation from the industry for 3.0 to 4.0 can happen, and how these technologies can be adopted by us, by the cement industry, and then how we can help them to adapt those technologies with ease. All right, so that's what is all about the presentation. So for me, I've chosen two topics, the production and the efficiency, right? And for that, we cannot, there are many tools available in the market, but I think we also need to set the KPIs for us. Okay, I'm looking for some solutions in the market, what the solutions can do for my plant, right? There has to be a KPI set for us, because I need to measure what is that I'm doing and then how it is paying back to the cement plants, right? So there are some guidelines, like how my kiln is going to be improved when it comes to the production, and what is the fuel saving I'm talking about, and what are the energy saving I'm talking about. It can be to the specific areas. It could be VRM, it could be ball mill, it could be roller press, or it could also be kiln. But before we start the project, I think we need to have the KPI set, and then measure it against that. Okay, this is what the digital project I have implemented in my plan. Is it benefiting me? Is the returns what I'm looking for? Is it the returns I'm gaining? How I'm making the progress on these returns, right? So that is most important thing. So we set the guidelines, we set the KPIs, and then we start the digitalization projects in the cement plant. So I've taken two topics, the two most important topic for any digitalization to the cement plant: the quality control and the optimization part of it. How they are linked, and how this can impact the whole cement process, right? The value chain is very important here when I'm talking about the quality control and the process optimization. So to start with quality control, we have seen the evolution in the QCX laboratory, right? So when we have the automated system, the sample preparation is important. How the sample is coming, at what time it is coming, and the right sample at the right time, and every time is more important, right? So the QCX laboratory automation helps you to have the right sample from the site. And again, the most important factor here is that we are avoiding the human factor. So when we have to take those samples at the various time zones, right, and at various timelines, we may compromise the safety part of it, the human safety part of it. So the RoboLab also addresses your human safety part of it, but it also means that we have the right sample at the right time. We are not having we have the samples which is repetitive in nature, and the specific areas where we decide what are the samples to be collected from site. So the Q6 laboratory automation not only helps in the having the right sample, but I think it also helps you to have the safety part of it when it comes to the human, right? But where the error comes from, is it from the sample collection, or is it from the sample preparation, or in the analysis process? If you see the whole 100% chart, right? So the sample collection is the where the errors are happening, right? how the sample is collected, at what time it is collected, and how it is being processed. So this is the important aspects of the quality control, right? We invest a lot of money on the equipment, but if we don't have the right sample, then I think the whole process uh, is not correct, right? To, to to correct it, I think the sample is the point where it has to be automatically collected, and that's the reason why the QCX RoboLab plays a vital role when it comes to the quality control part of it. Okay, now we have collected the sample. We also have the equipment invested to do the analysis, how to make auto correction, right? So it has to be in a closed loop. We have so many manual processes today. So as part of the digitalization, we need to make them automated, right? So the sample collection, then the analysis, and then the correction. So once we have this analysis from the XRF or XRD, that has to be fed to a software. So that is where the Q6 Blend Expert plays a vital role. It takes all those analysis and then all these characteristics, and then the raw mix control is done automatically, right? So today what happens is these samples are collected manually, the analysis are done manually, and the feed to the set points are given manually. So if those ratio set points are corrected automatically, I think the most the quality part of it is done, right, in a closed room. We know that the pyro process is critical, but what is feeding to the pyro is the raw mix, right? If the raw mix is quality one, then I think the output what you get from the kill is also quality one, right? So the basic corrections we keep doing it in the kill, but I think what we are feeding to the kill is also most important, and that plays a vital role. So the quality control part is the foremost important if we really wanted to have an efficient kill. So now I'm coming to the optimization part of it. Optimization, the process optimization can never be avoided, right, in today's date. And with the pyro is being the critical part of the cement process, and having alternative fuel and having WHRS as part of the pyro process, it's make more critical, right, in today's operation. It is humanly impossible for operator to run the cement plant efficiently, right? Yes, based on his experience, he can keep changing the set of parameters with the process changes, with alternate fuel, with the WHRS being placed. So the kill has to be optimized, the kill has to be efficient, but how much operator can take, right? So that is where the easiest process expert, the advanced process control, helps the operator to become an assistant to the operator, right? It takes over the operator, but I think you still need an operator. It will not replace the operator today, but that may happen in the future. But as per today, you need an assistant to the operator. So operator can work on other things, but changing the set point every second is humanly impossible. So that is what the easiest process expert does based on the various changes in the process, based on because of the alternate fuel, the changes happens in the process, because of the WHRS, the kind of changes and the kind of uh, uh, process instability happens, right? So you need to make those corrections immediately. So that is what the process expert does. With version 9.1, what we have launched, there is a adaptive control, self-adaptive control. Whatever the dynamic changes in the process, it adjusts automatically and then does the production control, and then it controls the plant, right? So it becomes an assistant to the operator. So because of this, what happens? There is the stability to the process, and then there is an efficiency to the process. I think at the same time we save energy, the electrical energy, and we tend to increase the production. Like we said, the KPIs in the beginning, right? So okay, I'm implementing this digitalization in my plant, but how, in what way it is going to help me, right, on the quality part of it, and also on the optimization part of it. So when it comes to the kill, when it comes to the pyro process, so the pyro process becoming complicated, right? It's day by day with alternate fuel. Once we have the alternate fuel, so again, the operator job is to increase the usage of alternate fuel, right? So there are situations where the kill really get disturbed, and then he has to put this PXP into off mode. I think with self-adaptive control, I think it helps also increasing the alternate fuel usage in the kill, and then see to that the process is stable, right? And then uh, as part of this process expert, the new version what we have launched, we also have come up with advisory mode where the whole when the kiln is disturbed, you don't have to put the complete PXP into off mode, right? So you know where the disturbances are. For example, the ID fan or the grade speed, wherever there are disturbances because of this process variations, right? Because of the process changes, you keep only those loops into the manual mode, and then still and the process expert keep continue to run in advisory mode, and then it is keep advising the operator how the process is behaving, what all the set points should be kept, right? So the process optimizations cannot be avoided and cannot be overlooked in today's date. With so many variations in the kiln, with so many process disturbances in the kiln, process expert, the advanced process control does its job, right? And once we have done this, so we also need to know how my kiln is behaving, how my kiln is performing. So that's the reason why we also have launched the dashboards. So dashboards gives you the there is a dashboard for sustainability, there is a dashboard for performance, and there is also a dashboard for benchmarking. So okay, my there are multiple lines today. You cannot avoid to have multiple lines in the production, right? So when we have multiple lines, there also need to be benchmarking that okay, how my kiln 1 is performing, how my kiln 2 is performing when we have this advanced process control, right? So that's the benchmarking. And how much improvement we are making, right? Okay, if the process expert run factor is 90%, what are my saving and what is my production increase? If it is 80% because of the process disturbances, how my performance are? So those performance metrics need to be monitored, and then the further improvements can be made. Okay, once it is installed, what is there further, right, for further improvements? So the remote monitoring and optimization plays a vital role, right? We have been talking about remote operations, right? And now we are also thinking that once you have an integrated unit and then there is a grinding unit, can this grinding unit can be controlled from the integrated unit? All those are going to come, right? And then the advanced technologies are evolving towards that. But before that, there has to be, so for example, once we implement this digital technologies and digital all advanced technologies into the cement plant, we need to monitor them, right? There has to be a performance monitoring as it is needed. What are the fine corrections need to be made based on the process changes? What are the alternate fuel you are keep adding to the kiln, right? And how the WHR is performing. So based on this, it requires a fine tuning time to time, and it requires a remote support time to time. So that is where the remote optimization helps to maintain the plant. And then whenever there are some disturbances, whenever there are some changes to the process, we keep fine tuning them and then put back to the KPIs what we had originally, right? It could be 3% saving, it could be 4% saving. It all depends upon the plant, how it is being operated, and then what is that we would like to be in the future, and what is that we would like to do with the plant once we have this advanced technologies implemented in this cement plant. Yeah. And then we also need to monitor them remotely, right? I think COVID has taught us that we cannot be disconnected from the plant. We need to be connected from the plant when the plant is performing. If it is not performing, why it is not performing, what are the KPIs to be watched, right? How the production is, how the energy savings are, where is that I'm lacking, what is that improvements need to be made. So there is a site connect app. It is a mobile app. So the mobile app, wherever you are in the world, right, can be monitored, how my VRM is performing, how my kiln is performing. So this is also important to being connected as part of the digital tools, as part of the advanced technologies. Yeah, I'm done with the presentation. It was a quick one because of the time limitations, but excuse me for my speed talk. Thank you,
Mr. Rizwan, it was
Rakesh.
excellent presentation. Though it was quick, it was very interesting one. And I believe there will be lot more questions for you during the presentation. We already could see some of them, but I think we'll take it towards the end.
Yeah, sure.
Thank you once again. So coming back to the main agenda of today, that is the panel discussion. Before I hand over the virtual platform to our moderator, Dr. Hegde, let me introduce him and the other panelists for today's discussion. So Dr. Hegde is a seasoned and accomplished professional with over 3 decades of expertise in cement industry, spanning leadership roles in India and internationally, with an exceptional track record in transforming operations, driving innovations, and mentoring the future leaders. He has held senior positions in cement organizations and is recognized globally as an authority in cement manufacturing, sustainability, and advanced concrete technologies. Then we have Mr. Hemant Aiyer, who has over 25 years of industrial R&D experience in diverse verticals of advanced materials. He has published over 60 international journal papers with and over 30 internal research publications, along with several patents and multiple technology development awards in different corporates. Dr. Aiyer has worked with many global organizations such as Tokyo Institute of Technology, Japan Science and Technology Corporation, General Electric, Crompton Greaves, Aditya Birla Group, Novo Vista Corp, etc. And then we have Dr. Raju Goyal. Dr. Goyal has over 33 years of experience in cement industry across Asia, Africa, Europe, and Oceania. He has extensive experience in safety, technical, project management, manufacturing, energy management, sustainability, alternate fuel and materials, performance management, capital and operational expenditure, M&A, product development, and commercial and procurement services. He is also actively involved in many organizations such as Global Cement and Concrete Association, CII, Niti Aayog, BIS, NCCBM, Cement Manufacturers Association of India, among others. Then we have Mr. Prasanjit Dutta. Mr. Dutta is a result-oriented project management professional with over 35 years of expertise in all facets of construction project management. He has a versatile track record for successful completion of high-value construction projects through coordination of all project processes, developing partnership with stakeholder encompassing R&D, information system, deployment and management, along with QC and QA, etc. Then we have Mr. Raju Vokuda. He is a seasoned technology leader with proven track record of driving digital transformation and operational excellence in cement industry. As the Chief Digital Officer at JSW Cement, he spearheads strategic technology initiatives focusing on AI-driven energy management, predictive analytics, and sustainability solutions. With a deep understanding of IT integration, automation, and compliance, Mr. Raghu plays a pivotal role in enhancing efficiency, resilience, and business growth. Our next speaker is Mr. Sachin Vaidya. With a robust background in digital transformation and change management, Mr. Vaidya has been instrumental in driving innovation and sustainable solutions across various industries. His expertise includes implementing advanced digital technologies to enhance operational efficiency and productivity. He has successfully led initiatives that integrate real-time data-driven decision-making processes, resulting in significant productivity improvement. And we have Dr. Rizwan, who just made a presentation. With this, I would, on behalf of First Constitution Council, I would welcome all our panelists for today's panel discussion. And with this, I would hand over the virtual dais to Dr. Hegde. Over to you, Mr. Hegde.
So I am truly excited to set the stage for what promises to be a stimulating discussion on the transformative role of advanced technologies in the cement manufacturing, because we have stalwarts from the industries. The cement industry is at the forefront of tackling some of the world's most pressing challenges, particularly sustainability and decarbonization, as you are aware. As many of you know, the industry contributes 7 to 8% of the global CO2 emissions, which has necessitated a profound shift towards low carbon technologies and resourceful efficient practices. This drive for sustainability has been the primary catalyst behind the adoption of smart technologies in manufacturing, in cement manufacturing. As the globe, the cement plants are leveraging state-of-the-art systems that integrate AI, IoT, robotics, blockchain, and digital twins to optimize every aspect of production. These innovations have unlocked remarkable efficiencies, sustainability benefits, and cost optimizations, while also setting the stage for more resilient and environmental conscious industry. Let me paint a picture of this transformation. AI-powered process control systems have cut consumption by around 10%, which is I have taken it from Lafarge Holcim from Switzerland, this number. Also, while the predictive maintenance using IoT sensors has also reduced unplanned downtime. Also, the digital twins, the virtual replicas of real-world systems, have helped plants simulate and optimize operations, lowering fuel costs. To ensure consistent quality, advanced lab automation systems are now in place, utilizing robotics for sample preparation and online XRF analyzers to provide real-time monitoring of raw materials and semi-finished products, clinker and cement. Furthermore, online analyzers for critical parameters like degree of calcination, pre-lime content, Blaine spinous residue, and environmental emissions, including NOx and SOx, and particulate matter, have transformed the precision of plant operations. In logistics also, AI-powered supply chain systems have revolutionized the inbound and outbound efficiencies. Cement backpacking is now automated with advanced systems capable of higher accuracy and speed. The truck and railway wagon loading systems are equipped with RFID tracking, ensuring seamless tracking, ensuring seamless timely dispatch. AI and machine learning are also optimizing inventory management, route planning, minimizing delays and wastage. On the operational front, innovations like autopiloting kill systems, cutting-edge fuzzy logic controllers, and integrated process control software have automated some of the most complex functions in the plant. These systems ensure enhanced stability, reduced energy consumption, and better equipment life. Sustainability remains the heart of all these advancements. The integration of waste heat recovery systems has allowed plants to convert waste heat into usable energy, while alternate fuels and raw materials systems are significantly reducing reliance on fossil fuels. Emerging technologies like carbon capture, utilization, and storage, that we call it as CCUS, are also making significant strides, offering promising solutions to the global emission challenge. In the broader context, the industry role in the circular economy cannot be overstated. Cement plants are co-processing industrial byproducts like fly ash, slag, and even municipal waste, demonstrating a commitment to resource efficiency. The use of renewable energy sources like solar and wind power is gaining traction, further aligning the industry with global climate goals such as net zero roadmap outlined by International Energy Agency IEA. Globally, cement plants are also embracing green certifications like LEED and environmental product declarations, that is EPDS, which emphasize sustainable practices and products. These measures not only enhance the industry reputation, but also align with expectations of increasingly eco-conscious stakeholders. However, the transition to fully digital and autonomous cement plants is not without its challenges. Cybersecurity risks have emerged as a critical concern with increasing reliance on cloud systems, SCADA, IoT, AI. The potential for cyber attacks on critical infrastructure is higher than ever. To combat this, the industry is investing in AI-driven threat detection, blockchain-based authentication, and zero trust architecture, that is ZTA, to secure its networks and systems. Today, we are privileged to have a distinguished panel of experts from major cement companies with us who will share their experiences and insights in how these technologies are shaping the future of the cement manufacturing. So already Mr. Rao has introduced the our power-packed panelists. Now we will start our discussions. Today we'll cover how AI, IoT, and digitalization are transforming manufacturing processes and other things in the coming time. So with this, setting the context for discussion, I will invite first Mr. Hemant Aiyer to start from him. Mr. Aiyer, I think
Yes,
you might have seen all the cement plants now. By this time, you are thorough with all the systems in your plants and other plants as well. So let me start with you with the question: how are these technologies helping cement companies improve time to market from that is from laboratory to market? And for the development of new products application, how do you find this? How do you explain these technologies are helping the cement companies? Please throw some light on this with examples.
thank you very much, sir. So I think the question is very pertinent to these days where time to market has to be skewed and made as fast as possible amid the huge competition in our industry. So I split that question into two parts. One is delivered quality. So because any new development, its success depends on the quality handed over to the customer. So I split as design quality and delivered quality. Coming to design quality, I think much is being modeling, where we can do so much of automation, so much of discussion is going on, integration of new technologies, while robotics can do very repetitive tasks, and huge automation is making us do optimization faster. Typical process case optimization is central to the cement. There is a concept of ionic liquid in this clinker formation or clinkerization process. And if you see and study that concept, and ionic liquid is central to many things, phase formation, even down to the grain size formation in a cement material. And these grains and these phases properties impacted on the properties. So when these processes are optimized properly, then it converts into the delivered quality by using appropriate, in this case of example that I quoted, appropriate thermodynamic software and tools of samples to be manufactured or created in the lab. When you come to lab, you have to again accept the testing. Testing in today's world cannot be a trial and error testing. It has to become a very newer techniques will emerge in the time to come soon, where huge libraries of these samples will be, for example, a sample library by 10 will make 100 samples to be tested at once in one go. That way you can speed up the testing and you can get the sweet spot of the product performance of both and then the delivered quality of successful new product development, and for reducing the time to market and for hitting the right products.
That means you have briefed us about the automation system and its utilization and its the benefits of consistent quality to be delivered.
Yeah, in our company, we are striving to address both the things, both from R&D and as well as the quality department is striving its best to address such frontiers.
Excellent, Dr. Aiyer. I hope all of you are getting my voice, isn't it?
Yes, yes.
There is some disturbance I think there is some weak signal problem at some of the, I think Mr. Iyer and you are facing, but I think we can manage.
Okay. I think it's a very good, a nice reply from Dr. Aiyer. About automation and the quality control systems, both process and quality. He has summarized it. And the advantages go to the customer. That is the most important thing. So now let me go to Mr. Goyal. My question and to take out your experience and expertise with lot of examples from your outside India experiences and with the number one quality cement company now. Mr. Goyal, how has this AI-driven real-time process optimization improved clinkerization, cement grinding efficiency, and overall specific energy consumption in cement plants? Can you share any measurable improvements and your expertise on this, please?
Thanks, Dr. Hegde, for the question to me. And good afternoon to all of you. As you know that now this AI, ML, and this digitalization, the keyword which everybody talking about nowadays, and sim industries also are roaming around that whole sphere. This, as Mr. Rizwan has mentioned that now in sim industry automation we have more than 16,000 parameters or signals and informations available, and it is impossible by the human to correlate and drive the decision to make the best decision to operate the plants. As Mr. Hegde mentioned that two part of the clinkerization and the cement grinding, which is the most energy intensive units in the whole cement plants. Up to 80 to 90% energy required in this whole process where we produce the clinker and grind the cement. Let's take the example of the clinkerization. And clinker process, as all we knowing that we are using the limestone, which need to calcination by using the fuel, burning the temperature, certain temperatures, and all this calcination process are happening, but a very small range of the temperatures. And further, the clinkerization happen with certain temperatures. Maintaining these temperatures are very, very important. Apologies. And if you put more energy or more heat, your product can be not as per the specifications, or if the less energy is not in the same quality which we need in the production this. So if you can have the real time informations, for example, oxygen, NOx, SOx in the process, temperature profiling, and your the torque in the clean, online information is available which can be seen, and trends can be correlated to say that what action taken, the preventive actions can be taken before things goes in other way around. So if you take the clinkerization process where the temperatures and the calcination process is a very important part of that, if I can say based on my experience on this, if you do the real time monitoring, AI driven decision making, you can reduce up to the 30 to 40% of the overburnt underburnt product on that one, which is the big money for all the operations there. Similarly, you can reduce the fuel consumption by doing that, because you don't need to over push or under push, and you have to take that action on real time where you can manage your process very accurately, and your losses becomes very less. As you also know that nowadays clean is not only the independent operation, now is related to the WHRS, is related to other operations or drying systems. So when clean process goes up and down, the side or upstream process also get disturbed. So this is also getting the much more beneficial in that. So if we say that in terms of the product quality point of view, I think can improve by 30 to 40% product quality can increase by the clinkerization. Similarly, up to depends upon the how the technology and the age of the plant and the automation you have, it can save about 2 to 6% of the your fuel efficiency can be further improved in terms of the your cost, because fuel is a very expensive material. Coming back to the grinding, because grinding which is the goes to the final product, as Mr. Hemant mentioned that he's the R&D guy, he knows that importance of the consistency and the quality into the product which goes to the customer. So in this case, if you have the online monitoring the PhDs or PhDs, sorry if my throat is not good today. So PhDs, all the particle size distributions and the blade and the residues, you can maintain the very, very narrow range, your product consistency and the power consumption in the grinding. Moreover, that the additives what we add into the process, which can be maximized also in that. And similarly, you can also put energy optimization. That means like if you have the ball mill, then degree of filling can be managed very quickly. And if you have the vertical mills, you can pressure and flows can be managed very quickly. In this process, you can reduce out 5 to 6% of the whole electrical energy can be optimized by that. And 1 to 2% or 3% up to the additives can also be optimized. The people who are from the cement industry, they can understand this number might look small, but impact in the cost, impact on the overall business is very significant. And as Mr. Hegde also touched the point on the sustainability, and you all know that every kilowatt you reduce in your process, you reduce 0.7 kg of cement per ton of material. And similarly, if you reduce 1 ton of coal or 1 ton of your heat, reduce that 2 to 3 kg CO2 can be reduced per ton of material. So this is not only impacting on the cost, but some significant impact in our environmental commitment or ESG commitment also. So real-time data, if I take the overall cement plants, 3 to 5% efficiency can be improved in all the aspects, and which can have significant impact on the cost as well as the ESG performance. That will be my take on this one.
Excellent, excellent, Goyal sir. When we started, this automation sometime in 2000 for Grasim cement business, now it is Ultratech. This ABB, we have taken ABB automation systems, plant automation, and as well as the laboratory automation system. So it was very interesting to learn because it was the first installation in India at that point of time, and we have learned so much of things about automation, process optimization, etc. through these softwares. They are really amazing. Nowadays, if you see this AI driven and the process optimization softwares in place, I sometimes, looking at the cement plant in the control room, I used to correlate with the autopiloting of the long haul flights, say, for example, Mumbai to New York, that type of thing is happening now. It's amazing, very interesting. Thank you, Mr. Goyal. Now I'll go to Mr. Rizwan with a question that how can this digitalization and process optimization technologies help cement plants improve efficiency, reduce costs, and meet sustainability goals? So this is, you can extend the extension part of your presentation and tell to our viewers and tell to our cement plant people about on these and throw some light about some of the examples if we have.
Thank you, Mr.
Dr.
Hegde.
Rizwan.
Yeah, thank you, Mr. Hegde. I think in today's date, right, the digitalization plays a vital role and a very important aspect of it. Because in cement plant, we have so many manual processes, right? If you see, even today we have a plant where the Excel reports are being made, right? You need to have so many factors involved in it. There are so many manual reports. There are so many phone calls, I think, before making the report. I think as part of the digitalization process, the first thing is to integrate the data. Right. So today we have energy data is coming from somewhere else. We have quality data coming from somewhere else, and the production reports are coming from somewhere else. Process data are being coming from somewhere else. These data are independent. And then if you have to make a report, if you have to make some dashboards, right, all these data are manually, it means feeding, right? You're feeding and then correcting those data, and they are never been correlated. You always have some final corrections to it. Right. So as part of the digital process, the first thing is that, because again, the integration process is difficult here because we have different systems here, right? The quality control is from somebody else, and you have a production reports coming from coming from somebody else. Energy system is from somebody else, but integrating them and then bringing them to a centralized location. So for the first thing as part of the digitalization is bringing them into together, in one form, right? That itself is challenging because we have so many systems. And again, the important aspect of digitalization is also that we need to look into our own system. Say, for example, when it is a new plant, you have a new system. But if you're talking about digitalization into the existing plant, it's a critical job because we still have so many systems which are obsolete, right? There are systems which are running in XP. There are systems which are running in obsolete, like Windows 7 or Windows 8 or Windows 10. Integrating them into a common system is not a small job, right? And again, we touched upon the cyber security part of it. I think when we are talking about digitalization, I think the cyber security is left. It is not addressed properly. It need to be addressed. I think the first step of digitalization is that please bring the system what is available in the plant to the latest one, right? To today's date, which can really deliver the output. For example, you want to have an interface because it is an obsolete system, because in an old system, it does not have those kind of interfaces, and you cannot bring all this data together, right? So the first thing is, as part of the digitalization, is that breaking all this manual process and then bringing this data together and then making the useful information out of this data, right? Making the dashboards. Okay, we are talking about the energy data. Say, for example, we have so many Excel sheets. Now, can we look at the screen and then say that, okay, this is what is the VRM power consumption is today, and this is how much production is. Where is the correlation? Right. So all those correlation can be done once the data is brought to a single system. So that is the first part of the digitalization. When it comes to the process optimization can happen in areas, right? For example, now my job is to first focus on the VRM part of it or the roller press part of it. You can do that. You don't need to do it. You don't need to implement it for the whole plant. So that is also the way to test it, that okay, is my process optimization is working, is the area where is the complicated area. Where, for example, we also have cement plants where maybe the ball mills are only in 80 tph or 90 tph. That is not the focused area, right, for the energy consumption. So the focused area is the roller press, where you have the more energy consumption. Pyro is the area. So start with the area where you really need an experience, implement it and see how it is being done. And for example, there are old plants where they want to get into the digitalization, but we also need to have the basic instruments. For example, we are talking about vertical mill. The bucket delivery kilowatt is important. The reject details are important. So these finite details are important. So for that, you may also have to install some instruments. So you need a kind of an assessment that what is that plant today I have? Can I straight away go into the digitalization? Yes, for some plant it is yes, maybe for some plant it is not, because we don't have the proper instruments. Okay, we need to monitor them. For example, if the mill load, how do I know the mill load, right? So do we have those instruments in place already? So I think we need to have that kind of assessment and then progress it. So you need to have a holistic approach when we are talking about this digitalization and also the process optimization. So all these areas has to be worked together, and then the energy saving, the real energy saving, because what happens is when you don't have these instruments, when you don't have this monitoring and the controlling parameters, then what happens is your energy savings could be less and your production increase could also be less. But when you have those instruments, your energy saving and the fuel saving could be much more, right? What we could expect from this. And in today's date, the process optimization can never be avoided. It is a must, and people have to go for it. And again, there is a mindset when we are talking about digitalization. There is a always kind of a neglection that what software can do, right? I think we are not undermining the operator capability here. I think we need to take those kind of mature discussions with the human, because there is an emotion involved from the operator that what is that I cannot do which operator software can do, right? And when we have those kind of political discussions, or when we have this kind of emotional discussions, we will, I think somehow it's a human nature that we will not allow the software to run, right?
Yeah.
So it will be
Yeah.
switched off shortly. So it requires a holistic approach,
Yeah, Dr.
but I think
Rizwan, you
it
have
can do
touched upon
wonders.
a very,
Yeah.
yes, yes. So you have touched a very pragmatic and, the practical things, what is happening in the plant. So digitalization will not happen automatic. As you said, the data is coming from different types, from different equipments. And in some of the plants, people are also using SAP softwares for different, the modules. So how to take those data from SAP from different modules, put into this type of, the digitalization mode with your software or somebody's software, and how to make the data in a way so that it can accept the digitalization, and you can make a sort of, the study, or take out to take a, the conclusion from it. That is the most important part.
Yeah.
So that we'll discuss over a period of time, maybe in the future.
Sure.
Okay. Thank you very much for your,
thanks.
detailed explanation. Now, I will go to Mr. Sachin Vaidya. So from ABB, and ABB, when I say ABB, I will remember his headquarters in Switzerland. Mr.
Most welcome, sir.
Vaidya. Okay, so we'll ask some question to you now. The
Yeah.
question is, with the increasing adoption of digital solutions in the cement industry, how can data analytics and actionable insights help improve operational efficiency and decision making?
Yeah. So first of all, good day, everyone, and thank you, Dr. Hegde, for having me here as a part of panelist. As briefly talked by all panelists earlier, Mr. Goyal as well as Mr. Rizwan, Mr. Aiyer, ABB has been partnering with cement manufacturers in terms of digital transformation journey. As Mr. Rizwan also outlined, digital transformation is not optional or nice to have things nowadays. Rather, how can we improve on investments which we have done in terms of driving more profitability, including sustainable operations. So ABB's approach in terms of driving digital transformation along with our cement manufacturing partners, we work into three primary areas. One is the process area, second is the equipment or asset reliability area, and third important aspect which at a time gets ignored and rather not given much of importance is the workforce. Because this industry also required to, I would use a word very consciously, bit of glamorization in terms of technology to attract new generation workforce. Because getting those talent working in this hard industry is very, very difficult nowadays. And how do we keep our technology up to speed and up to date? It's really important to get those manpower in place in order to drive safe, sustainable, and profitable operations. So when we look at digital solution adaptation, if I focus first on process part of it. So when we look at digital solution deployment, as Mr. Rizwan also outlined, process area digitalization, be it APC, be it energy management solution, or be it quality related solutions, including laboratory, etc., really help in terms of driving advanced analytics, as Mr. Raju Goyal also said, using AI ML into this area, because now new generation APCs are self-healing, self-adapting APCs, which are very highly required due to change in AFR strategies and how do we optimize the cost on fuel mix, in temperature, grinding efficiencies, etc. So driving highest quality with the lowest cost and with saving of energy, this plays a very important role when you adopt digital solutions like APC and energy management solution. The equipment, at a time we drive throughput very high and we ignore the health of the equipment. So, and we end up in having unplanned downtime. So be it vibrations or be it temperature sensors or energy consumption related to equipment, which is also optimize the cost of the production. So if we implement smaller condition-based monitoring solutions, and based on those initial startup of condition-based monitoring solutions, if we start building analytics on top of it using predictive maintenance and preventive maintenance, it helps in terms of reducing downtimes and also extend the equipment life. And you can also better plan the maintenance schedule. And as you mentioned that a lot of plants are going with ERP, SAP integration. So you can actually integrate all of this from shop floor to ERP integration, including the automatic work schedules or maintenance schedules, etc. Third important aspect is workforce safety and how do we attract the talent. So we need to bring a lot of technologies in terms of adaptation of digital solutions like operations rounds or inspection rounds, be it sample collection systems, etc. There are various hazardous working conditions in the plant. So using these technologies really help in terms of improving our workforce as well as safety management in the plant. So all in all, digital solutions, adaptations, and integrating them from IT/OT perspective really help in terms of bringing operational efficiencies. Whenever shift changes, we always have seen plant throughput is being changed. This is based on experience operations versus new people who are coming on the board. So when you want to drive consistent operational efficiency and improve decision making, be it remote operations, digital adaptation solutions, or digital solutions deploying using secured cybersecurity, data transfer between IT/OT plays an important role here. So in a summary, if you want to drive cement operations into more safer, sustainable, and profitable way, adaptation digital solution is no more an option. So that's how I'll conclude.
Digital option is a mandatory now.
Yeah, it's a
It's not
mandatory
option now
because
to survive.
yeah, absolutely.
So what is required, all those things, to you and Dr. Rizwan and everybody, even for the technology suppliers point of view, what is required for the cement plant is so much of data analytics, data is coming, and data analytics things, softwares are there. So what is required is for the cement plant people, they don't get much time to look into this data, because some problem or other is happening in the cement plant. Suppose I am started sitting now, I am sitting with you to see the data. I will have a call. Something has happened at the site. I have to rush to the pleater. I have to go to the site, etc. So the time availability for managers as well as for engineers, because of the so much of complexities in the cement plant, the time is a constraint. So what I suggest for the technology suppliers is how best, in a very friendly manner. So if it comes, the data comes with the different, clear
actionable insights.
actionable insights. That will be a wonderful thing, and cement plant people will thankful to the technology suppliers. So that is what is required.
Yeah, definitely, Dr. Hegde, your input is most valuable, and we have been working with various our manufacturers like Holcim and other global, including Ultratech, Adani, everyone, in terms of deploying those insights.
Yes, thank you so much, Mr. Sachin. Now I'll go to Professor Dutta Sahab. So for Mr. Dutta, the question is the energy consumption tracking and monitoring is crucial in cement plant, as you are everybody is aware. So how are cement manufacturers are using AI to optimize energy use, to reduce waste, and enhance operational efficiency? Your insights, Mr. Datta, and your experience and expertise.
Yeah, first, let me thank you all. Thank First Construction Council for inviting me to this webinar. See, my expertise is basically more towards the construction of the plants than the running of the plants. But with my very limited knowledge, what I understand is cement manufacturing is a very energy-intensive process. The biggest challenge is basically achieving energy efficiency. Now,
so what is your, Mr. Datta, just to interview, I'm sorry for that. What is your background? You said something.
I'm basically a project management consultant. We are into project management. We offer project management services to cement plants construction.
Okay.
That is what my company does.
Okay.
We are more towards the consultancy side.
Okay. Can you throw some light on this question?
Yes. See, now, basically,
please go ahead.
When you want to achieve energy efficiency in cement plants, there are several solution providers who are coming up with AI, IoT, and machine learning based solutions. Now, I will mention a few of them. The first solution that is available to us is basically developed by Siemens. It's the AI-powered energy management system, EMS. EMS basically does a few things like smart energy monitoring and optimization, predictive maintenance, process automation and AI-driven controls, integration of renewable energy and smart grids, and CO2 emission reduction and compliance. Then we have our friend from ABB, he will be able to throw much more light into this. But ABB now has AI-powered smart sensor technologies which are available to the cement plants. Now, what this particular technology does is predictive. It helps in predictive maintenance and asset health monitoring, process optimization, energy efficiency and sustainability, wireless and cloud-based monitoring, safety and reliability. I think Mr. Vaidya has already talked in details on this. The third option that is available, the third technology that is available is from FLC. It is AI-driven process control system. I will not get into the details because Dr. Rizwan has talked about this in details. The fourth technology that is available is basically digital twin AI technology. Now, digital twin AI technology benefits are basically in the areas of predictive maintenance, energy optimization, production efficiency, sustainability and emission control, and scenario testing and simulation. So these are the current technologies which are available for bringing down CO2 emission in the cement plants, as I am giving to understand.
Very good, very good. Very nicely summarized, Mr. Dutta. So now I'll go to Mr. Raju Vokuda, young and dynamic from B Hegde Cement. So IoT-enabled real-time data analytics is revolutionizing the manufacturing, as we all are aware. How are the cement companies leveraging IoT sensors to optimize fuel consumption, cooler efficiency, and emissions reduction? Your take, Mr. Raghu. Can you throw some light on this?
Sure. Thank you, Dr. Hegde, and good afternoon, everyone, to the industry experts on the panel. When we talk about IoT sensors, the first thing that we think about is, how do we talk about predictive maintenance? I mean, from the days where, what we have been learning and reading about how to be reactive and preventive in terms of the maintenance is concerned, to how we have changed to becoming proactive and predictive. So IoT sensors have played a key role there, which I'm sure all the panelists will agree with me. But coming to the question that you have, Dr. Hegde, I think I will second, Dr. Goyal's view, as well as I think one of the panelists mentioned, it's a combination of things, right? I mean, I don't see that IoT sensors alone can talk about, I mean, they would add to the optimization as a process as such, but yes, it is a combination of, various aspects of, looking at APCs, optimizers. You have panelists who are, promoting that here. Well, they definitely do play a role in that. And similarly, if I look at, for example, kiln performance, if you are talking about monitoring them for the temperature, pressure, fuel air, mix ratios, and so on. I mean, these sensors would definitely come and, play a role in that. Apart from that, the combination of, alternative fuels can come into play. The waste heat recovery would come into play. So I think those things will definitely add to the combination of what we're talking about, and then, a percentage. I mean, the panelists here from the product side probably would vouch for 3 to 4% of fuel saving using those solutions that are well tested, time tested, right? I mean, and along with these additional, process process interventions, especially on the AFR or the heat recovery aspects of it, somewhere close to 4 to 7% of fuel savings is something that we can look up to. And coming to the cooler efficiency aspects of it, I mean, definitely these sensors can be used for adjusting airflow and, optimizing heat recovery, which can add to about the same percentage that we spoke about. And coming to the emissions part of it, yes, there are that's the talk of the town now. Sustainability is something that everybody is looking at it, considering where we are, and 7 to 8% of emissions coming from cement industry globally. I think that's something that if you look at US or the the European councils are bringing in stringent measures, and so will India have to follow at some point in time, though we are already working on it, I'm sure. So if you look at the NOx, SOx, CO2 monitoring, I mean, that could be very helpful using these IoT powered, systems, and also some kind of predictive emission controls that can come into play, which can add to 8 to 10% of, reduction in, emissions. And over and above, as JSW Cement, we are the lowest carbon, emission for that. That's about the lowest in the industry. I mean, we have about 270 kg per ton cementatious material because of the processes that we follow at JSW Cement. But yes, like coming back to your question, I think it's a combination of the APC or the optimizers along with the IoT sensors, as well as the processors that are like the AFRs, and as well as the heat recoveries that come into play, which add to these kind of optimizations across.
Very good. Very excellent.
Sure.
So at this point of time, what I can summarize is that, now we are in a process of installing Industry 4.0. So while we are in a process of, adopting Industry 4.0, what is required is from the point of view of technology suppliers, and what is required as a manufacturer of cement, what I will expect from the technology suppliers is, make the people aware that these are different systems are available, IoT sensors, and so many, advanced systems are available, and how this can be implemented plant-wise. You cannot generalize. What I will believe is each plant is unique, like, each baby is different, is a unique. So what is required for the cement companies and the plant people is technology suppliers have to interact, go to the cement plant, show the system, and convince them these are the different things in a very, very simple way, so that, because as you are aware, the absorption level in the cement plant may be good, may not be so good. So what is required is go to the cement plants with all very simpler version and make them aware, and then what is the benefit out of it, and then you have to make them feel that these systems are really wonderful systems for many things, many KPIs. Each plant has got it, and it can be implemented in a near future without wasting time, quick mode. So that is what is required. So I think we have completed one round. Then we'll go to second round of discussions. So in this second round, what I will request each panelist is restrict your answers to 2 minutes time, because of the time given by the organizers now is that. So according to that, my request is to follow 2 minutes answer session for each of you. Now we'll start with Mr. Sachin Vaidya. How does the integration of IT and OT systems enhance process control, automation, and overall performance of the cement industry?
Yeah, so thank you, Dr. Hegde. It is important, as I mentioned earlier, digital transformation or digital solution adaptation is no more optional. As we look at Industry 4.0 revolution, initially people were resistant to have automation itself. Based on ISA 95 guidelines, a lot of systems have been deployed from level 1 to level 4 or level 5 at a time at enterprise level. So today, based on digitization requirement in the plant, IT/OT integration is must in order to reduce silos. And how do we bring a lot of data, as Goyal sir as well as Rizwan mentioned, like there are 16,000 plus of signals available. How do we make these signals or data which is available into silos used into more of driving actionable insights and improve the overall plant performance? So in terms of process optimization, when you implement APCs on ISA 95 stack on level 2.5 or 3, it basically helps you in terms of improving your automation. when you implement PIM systems on level 3.5 with the secure data connections with IT/OT integration, you're able to drive more actionable insights and even including remote operations. And even automation and robotics involvement in terms of laboratory, very hazardous areas, improve the operational efficiency. So in summary, basically, it also help you in terms of bringing the data together and drive more and more actionable insight. Even now, the future is autonomous operations. How can we operate plant remotely? We can have talent together, give actionable insights to plant people, including the safer workforce. So IT/OT integration is must as a part of digital transformation. It even optimize your end-to-end supply chain across the plant. So in summary, this basically drives data-driven decision making, provide more analytics, more predictive actions, which will help in terms of reducing downtime and real-time process optimization. So only thing we will have to drive is more secured IT/OT integration, which we'll cover in the next part of discussion.
Thank you, Mr. Sachin Vaidya. Now I'll go to Mr. Goyal. Predictive maintenance using IoT, AI-based sensors is reducing downtime in many industries. How are cement companies implementing these technologies for kiln, vertical roll mill, and packing plants? What reduction in the equipment failure rates, maintenance costs have you observed? Can you please throw some light on this, Goyal sir?
Thanks, Mr. Hegde.
Yeah.
And thanks, Mr. Sachin, for making my life easier to answer this question of Mr. Hegde. So as we all know that in cement industry, so this is a 24 hours, 365 days operation, this continuous operation there. Any unplanned stoppage is having the huge cost. One of my previous speaker mentioned that. So I put the number on that. It can be 20 lakh rupees to the 70, 80 lakh rupees per stoppage, depends upon the quantum on this. So as Mr. Raghu mentioned very nicely in that now we are moving from the corrective to preventive to the predictive. And predictive analysis is more efficient in our processes because if we can predict the breakdown and prepare for that breakdown very easy in advance, arrange the material, arrange the people, arrange the all the resources required for attending the breakdown. So reduction in the breakdowns are the key parameters for in this predictive with the IoTs and all the sensors which we are putting into the systems. And let me put the numbers on that as Mr. Hegde asked me that. This predictive maintenance or predictive mechanism can reduce your unplanned shutdowns by 30 to 40%, which is the significantly can be reduced in this one area. And putting the cost of the maintenance, which we all are worried about that, it can be in the range of 15 to 25%, depends upon the size and what is the type of the breakdowns and things are doing. So predictive maintenance can really reduce the maintenance cost. And if you take the availability or the like I call the runtime availability or OE kind of a things, which can reduce can be increased by 10 to 15%, depends upon where we are operating on that side. So especially like if you predict the what is the refractory lining life is remaining, what the girth gear refractory lining remaining, what are the internal information you get it without stoppage you can get it. And similar like a vertical mills, the gearbox, which is the most expensive equipment on that, if you put the dialogue system or automation can be done or information real-time information can be given, the vibration, temperature and things you can predict and you can stop before things can go disaster in that side. So this is the way predictive maintenance is helping with the help of IoTs and AI based and on real time informations on the system. That is the information I have.
Great, Goyal sir. Now for cement manufacturers, what is required is to reduce the cost of manufacturing. That is the key. Because of late, I think we are aware that cement companies are because of subdued demands and input cost increase. Manufacturing cost has to be minimal with less downtime, and also about the planning of by using predictive maintenance system. That is the key for decreasing the cost of cement manufacturing. That is the key now. So overall, how to improve the EBITDA, that is also very important. Thank you, Mr. Goyal. Then I'll go to Mr. Rizwan. What are the key challenges faced in pyroprocessing within cement production, and how we can how this advanced process control and automation technologies help improve efficiency, stability, and sustainability in the critical stage? You have got 2 minutes to answer.
Yeah, thank you, Mr. Dr. Hegde. I will keep it short. As I said in my presentation, right, the pyroprocessing being the critical process of the cement manufacturing, right, and it is heart of the plant. As Goyal said, it has to be run. It has to run 365. There is no even one unplanned downtime can cost you 80 lakh rupees, right? So to make it efficient, pyroprocessing, I think we keep focusing on pyroprocessing. I think with process optimization, it is done. It is must now, right? So it is not to challenge the operator, but I think it is to complement the operator. That okay, I think it is also has to own by the process people, saying that okay, I'm implementing this APC process optimization into my kiln. I will ensure that this is what the production is increased, this is what the energy saving is done. So they have to own this software, they have to own the KPIs. It is not that somebody else is pushing them to implement it, so it will never be owned by them, right? Okay, that is on the process optimization. And when it comes to the pyro processing, I think we also forget about what we are feeding it to the kiln. If the kiln burnability has to be better, I think what material what you are feeding to the kiln has to be better, right? So that is where I'm keep on talking that the quality control part plays a vital role. So whatever is the raw mix, if your raw mix is perfect, if it is homogenized, and that is what, if you are feeding it to the kiln, your kiln output is going to be better, much better, and your burnability is taken care, right, when you have this right raw mix. So pyro process is the important part of it, but I think the process optimization and the quality control in raw mix and the process optimization in kiln can work together, and then can give you the results which you don't expect it. Like the numbers what you're talking about, 2 to 3% or 5%, I think it can give much more than that when these two work in combination.
Excellent, Dr. Rizwan. You are perfectly on time.
Thank you.
Then I'll go to Dr. Hemantkumar Aiyer. I think the question is, what changes are you seeing with respect to usage of modern equipment and technologies in the area of R&D in the cement industry over the years? Mr. Aiyer, if you want to go early, you have to answer to be very quick. He has got a board meeting, I think, at 5 o'clock. Mr. Aiyer? Dr. Aiyer?
I think you're on mute.
Dr. Aiyer,
okay,
you are on
sorry,
mute.
I noticed it just now. So I was telling that biggest advantage today we have the big data analytics, AI, ML, and added to top of that IoT, which is emerging as a remote control set for the industries. Now, one single thing that is helping R&D, helping industry going forward is reduction of errors. Reduction of errors, and much was talked by previous panelists, corrective, predictive, and preventive. All these are referring to the errors. So we will minimize the error, and the ideal dream and the target is to eliminate the error. And these fall in three categories: materials, measurements, and the methods. Materials, as just now Mr. Rizwan was telling, what materials we feed into the system are going to determine the eventual product and the properties of the product. And coming to the measurement point, he only, again, Mr. Rizwan also told us right in the beginning, 80% error is coming from sampling of the materials, and 15 from the preparation, and 5% from the analysis of the eventual measurements. So the measurements, again, errors will be reduced by proper evolution of these new technology assets. And finally, the processes, where a lot of talk and lot of evolution is happening on the optimization of processes for right kiln efficiencies, even in the areas like AFR and eventual TSR, where exactly you feed these materials into the system will determine the eventual efficiency and the TSR levels. So everything is coming to a single point to my mind. The errors in each of these material methods and measurements will be reduced and is the governing factor as the combination of technologies play a central role. Thank you.
Excellent, excellent, Dr. Aiyer. I think we are releasing you on time.
Yeah.
For the
I
board
will have
meeting.
to exit. I am sorry about it.
It's okay. It's part of life.
Yeah.
You answered pretty well,
Yeah.
Dr. Aiyer.
Thank you. Thank you.
Appreciated.
Thank you.
Thank you, Dr. Aiyer, for your participation.
So I think for R&D in cement companies, what I observed in India, many of the big companies have got a beautiful R&D setup. What is required is take the advantage of those sophisticated equipments utilization, number one. Number two, at the advent of the LC3 cement in our India with the BIS license and all, what is required is some of the equipments like DTA, TGA, etc. are required for the characterization of different type of clays to find out its the at what temperature this metakaolin will be formed from the particular type of clay. That is what is required. Those equipments, they are sophisticated equipments, are necessary for the characterization of these clays for manufacturing of LC3 cement. So now I think we'll go to the next round of questions. I will go to Dr. Mr. Prasanjit Dutta. The question to you is, cement production is one of the largest industrial contributors of global CO2 emissions, that is around 8%. So what kinds of technologies in climate control are available for cement plant construction, according to you? Your views, please. Mr. Datta, 2 minutes. You are on mute. You are on mute. Unmute, please unmute. Yeah.
Yeah, I'm sorry. There are quite a few cement control technologies which are available, which can help reduce environmental impact, enhance the energy efficiency, and improve operational sustainability. We can start with carbon capture, utilization, and storage, which is typically known as CCUS. Use of alternate fuels and renewable energy can be a game changer at some point of time. Another area is basically using low carbon cement production, smart plant technology, and AI optimization, which we have already discussed. Then there are advanced kiln technologies and sustainable construction materials and techniques. Basically, these are areas which can which can be climate friendly solutions to. If we talk about CCUS can help in climate mitigation, energy transition, and it has a huge economic potential. If we talk about alternate fuels in cement production, it has alternate fuels that lower CO2 emissions. It can reduce waste and it can save cost. Renewable energy is something which is new to cement production, but already there are researches going on for use of solar power, wind energy, waste heat recovery, and geothermal energy. Alternate fuels and renewable energy sources offer a sustainable pathway in reducing the environmental impact and environmental impact in cement production. I mentioned about low carbon cement production. Low carbon cement production is basically the way forward in reducing global CO2 emissions. Last but not the least, advanced kiln technologies and sustainable construction in construction materials and techniques. These are the way forward in climate control.
Very good, Mr. Datta. For your summarizing all those, avenues for this. Now I'll go to Mr. Raju Goyal. The question to you is, as you are aware, cement manufacturers accelerate their digital transformation. What key technologies and strategic initiatives are essential to building a model digital plant? that maximize efficiency, ensure sustainability, and ensure operational resilience. How can AI, IoT, digital twins, and autonomous systems be integrated to create fully atomized and future-ready plant? So you can divide the answers into two parts. Up to enhances operational resilience by using these digital technologies. And then you can talk about AI, IoT, digital twins, and autonomous systems.
Got it. So, Dr. Hegde, I'll probably summarize it in a way which would probably make you know bring some more light to this question. One of the panelists mentioned about data in silos and so on. I mean, cement being where you have organic, inorganic growth that's happening across, right? And the reason why we see this kind of challenges is data residing in silos. First step. So I look at it. The way I structure it in my mind is we need to have something like, what the reason why we have data in silos is because there have been decisions made for a particular intervention, a digital intervention, long time back, which was happening at the plant. So that was a local decision made, and hence a local solution was, procured and implemented. But as we move forward, I think the way to look at it is we got to think central and act local, so that you are able to see and envision what's the way forward for the particular cement plant, to call it a model digital plant. And if you have to structure it like a framework for it, I would probably look at how do I want to integrate, how do I want to automate, and how do I want to build intelligence on top of it across the levers like operational efficiency, plant maintenance, quality, safety, sustainability. Last but not the least, a smart workplace. How do I bring in automation? How do I bring in integration? And how do I build intelligence on top of it? That's my 2 cents on how I am looking at it. If you talk about building a model digital plant, using these kind of advanced solutions which are there in the market today, this is the framework that I go with, and that's the way forward for a future ready cement plant is what I believe. Thank you.
Yeah, if you implement all those things, the cement plant will look differently. It will look differently. So for that, the integration and understanding of the systems, and how we have to integrate the one system into another system to another. So that is what is required. The multidisciplinary approach is required to take the best advantage of these emerging technologies. Thank you very much, Mr. Vokuda.
Thank you.
Then I will go to the next round of question to Mr. Rizwan. That is, what is the cement industry moving towards sustainability? How can plants prepare for these changes? What are the key technology trends shaping the future of cement production? 2 minutes.
Yeah, thank you, Dr. Hegde. As you
Yeah.
mentioned, I think the plant people are busy, right? I think I think we need to give time, because when you want something to be better, I think we need to give time. If you don't give time, I think I've seen in several discussions, right? The discussions happens, but I think after 2 months we forget about it, and then we restart from the low wall. I think it will not work out. I think there has to be a cultural change. There has to be a mindset change, saying that the software can do wonders for the plant, and it is doing. And who will be the loser who don't understand this and then who don't implement it, right? And it is a beautiful thing. It's a multicultural thing. It is a multi-thinking prospect. As Raghu said, you need a central thinking, but I think you need a local implementation, right? And now all these implementation are happening in packets. IT is working independently, OT is working independently, quality is working independently. I think we need to have that holistic approach. We need to have this cross collaboration, right? Okay, I need to better my product. What is that I need to do? There has to be something be done in the electrical. There has to be something done in the mechanical. There has to be something done in the automation. So digital is not about only automation. Digital is not about only instrumentation. I think it is a group of people. It is a group of mindset. I think we need to come together and then deliver it. But I think, as I said, we need to have the KPIs. Okay, I'm going to do this. What is that my KPI? How much energy savings I'm going to do? What is that? I think we need to carry that as a proud that, okay, I will improve the energy by 5%. This is my goal, and this is what I'm driving towards. I think if we take that as a goal project and then we do it, instead of taking, okay, this is the software I have, can I implement it? No, I think that doesn't work. Then what happens is, then we become a research center, right? We call one vendor, we do something, then we call another vendor, we do something. But I think at the end of the day, we don't deliver it anything. Right? We keep discussing it. So I think we need a holistic change. We need to have a cultural change. We need to have those kind of thinking that yes, it does, and we need to deliver it.
Excellent, excellent. I can understand internal insights from your talk that that has to be percolate. Implementation of the new systems and adoption of the new systems to the very efficient way to run the plant, that has to percolate from the top. Okay, number one. Number two, the plant people should be motivated to implement such new technologies, understand the new technologies, and then implement it. That enthusiasm has to be there. Then the implementation will be perfect. The motivated team is required, and it has to percolate. The dynamic leader is required so that he can drive the things in a better way.
Yes.
Thank you very much. So we'll go to now the last round of the question answer sessions. This is to Mr. Goyal. The question is, the cement strength and durability are critical. How are digital tools like machine learning based on lab testing, real-time XRD, XRF analysis, and automated quality monitoring enhancing cement consistency? What do digital twins play in quality optimization? So you can divide it into two things, for the cement strength and durability aspect, and then digital twin for quality optimization. Mr. Goyal.
Thanks, Mr. Hegde, for the loaded question actually. For this. So as you rightly said, this durability and strength is one of the key parameters for the cement application in the construction industries. And as you also mentioned that the consistency is the key, other than the strength and durability. But again, consistency is very much important for the any application in the cement, in the concrete specifically. So machine learning based lab technology or tools are the very important for us to understand, to predict what can be the cement or concrete strength can be. And you know that nowadays people are talking about a lot of soft sensors where you can put the information into the input of the mill, and you can get the, before material comes out, you can get the 28 days strength on 1 day strength, and 7 day strength can be predicted very quickly on that side. So this kind of a predictive strength, if you can do that one, then you can very quickly correct your raw mix design, especially in the mill inlet or in the clean inlet, which is the, you can control the quality very quickly, so your defect into the materials can be reduced significantly. And yes, XRF XRD real-time analysis is a very key important aspect, because they provide the detailed informations of the elemental analysis as well as mineralogy of the material, which can be corrected, and material if required can be changed very quickly. So it will help the automated quality control monitoring systems. And sorry, my throat is not. So real-time monitoring and removing the defects in advance and putting the quality as correct as possible into the system. And coming back to the digital twin, yes, digital twin is playing very important role for doing the experiment, making the mix designs and everything outside the system before you put into the practice and that side, which is helping industry to understand the behavior and optimize the process, in not only the process but quality control also, optimize the quality requirements, because nobody want to give more, nobody want to take less, and this quality consistency will definitely will be the key factor for the durability and the strength development in the cement concrete. Thank you.
So thank you very much. I think this is wonderful thing. Cement strength and durability are the very predominant parameters, and that is what is required, because of late we are seeing the concrete structures are prematuring and getting spoiled as per the design strength. For example, it has to be there for 100 years, but we can see the distress condition of the concrete structures around 30-40 years of time. So many things are there, and these equipments will be very helpful for predicting the strength and helping the construction industry as well as cement manufacturers. So now I'll move to the next question to Mr. Sachin Vaidya. This is the manufacturing becomes more connected. Cyber security is growing concern? What are the key risks associated with IT/OT integration in cement plants, and how can we mitigate it? Because this is a very important question, Mr. Vaidya.
Yeah. So
Cybersecurity.
thank you, Dr. Hegde. As I mentioned earlier, like IT/OT integration is extremely important for digital transformation, driving informed decisions and operational excellency. Operational excellence. So at a time, even as a technology provider, I am finding it difficult to convince cement manufacturers in terms of importance of cybersecurity. We cannot verify or we cannot measure everything against tangible benefits. Some of the things really need to be done as requirements or basic infrastructure requirements in terms of IT/OT integration. I hope we continue to improve awareness and knowledge around this. Obviously, because of IT/OT integration, network vulnerabilities, cyber attacks, or malware attacks is expected, or that risk is there. But there are preventive measures in order to have proper reference architecture done, secure data transactions, network monitoring, and educating our team in terms of insider threats like avoiding human errors, using flash drives, etc. in the servers. Those kind of learnings and continuous awareness and trainings are really helping us in terms of preventive cyber security issues. Cybersecurity, I sincerely request all the cement manufacturers to consider it seriously, because as you go into digital transformation, there are solutions required around it, and there are solutions available. Technology providers are ensuring that their systems are cyber secure. However, there are certain activities which required to be on the network side, which required partnership with the technology providers in order to ensure that the IT/OT data security is maintained and monitored on regular basis. So obviously, this is, again, I'm repeating again, but this is not an option. This is must and important aspect of digital transformation journey.
Yeah, this is very much very nice, Mr. Sachin Vaidya, because digitalization, this is when we embrace the digitalization process, the side effect of this is, you know, the cyber attacks. So you might be aware that even in ordinary, in our common life also, people are losing so much of lakhs of rupees of money because of, you know, the online and digitalization. But what is required is that even cement plants, maybe the cement plants malfunctioning and it may stop working. So those things can happen. So
yeah,
what
it's a very difficult situation if there are any downtimes, and we have seen a lot of these attacks. Sorry to interrupt you, but cement manufacturers are still feeling that we will not be targeted, which is not the case.
This is not the case, because this is, the awareness is not there. The awareness and seriousness is not there. So generally, you know, when we experience, then the seriousness and awareness will automatically come. For example, if I lose 1,000 rupees because of, you know, the fraud or the cyber fraud, then I will remember up to lifetime. I will not do any, you know, the mistakes. If I got a call, I will not make any mistake. If somebody says that I'm from the bank, you show me this, that number, OTP, I will not do it. Nowadays, people, so much of awareness has come because of the continuous frauds, cyber security frauds. Therefore, people are not even lifting their phone also. And this is the reality. Okay. So now, thank you very much. Then we'll go to Mr. Raju Vokuda. Fully autonomous plants using AI, robotics, and digital twins are being tested globally. Do you see Indian cement plants becoming 100% automated in the next 5-10 years?
Well, fully autonomous plants, well, I'm skeptical about it. In the next 5-10 years, I think Indian cement plants will see huge, significant automation that will happen, no doubt about it. But I think the way forward would be a hybrid model, which is AI-powered decision-making plus a human oversight, is something that will be more relevant. And also we need to understand that, you know, when we're talking about comparison to the global or developed countries, the automation might not necessarily yield the results like the way we want when it comes to India, considering the low labor cost as well. Having said that, I think the few challenges that might come across would definitely be in terms of the digital twin maturity that we're talking about. Today, we have a lot of people talking about digital twin. We're talking about more of process twins here rather than asset twins, and the kind of leverage that the European cement manufacturers or anybody else there are using vis-a-vis what we're doing in India. I think we're still in the nascent stages. So I mean, that kind of maturity is still there. And we're talking about edge computing and 5G edge computing still coming into play, because we're talking about huge data packets to be sent across when it comes to AI ML models to be built, right? Which requires ultra low latency networks. So I mean, I think still we are not there in terms of technology challenges, if you say so. But coming to the other aspects of it, workforce, obviously we know what we're talking about in terms of the change management, the resistance, the cultural shift that one needs to have, considering jobs insecurities that comes into play and so on. And upskilling the existing plant operators to understand the AI-driven process controls. How do we go about it? In terms of training them is also very important. Last but not the least, I think the overall view would be how do we want to look at the capex versus the ROI that comes into play. Obviously, there's going to be a long-term ROI outlook to these kind of high investments that we are talking about, which requires the key stakeholders' engagement as well as onboarding of them to be convinced about the ROI returns, which usually is a long-term outlook. So I think these are a few challenges that I see, and but yes, fully autonomous in the next 5-10 years, I might not be. It could be a combination, as I say. I mean, it could be a hybrid model. Thank you.
Yeah, exactly. But what my feeling is that we are a very young country, and we are producing so many lakhs of engineers every year. So because to adopt and implement this type of the AI based and IoT sensors, etc., which needs the engineering brain. So the change management has to happen. The management, the recruitment type of that conventional system of recruiting people are to be changed into these engineers, so that these people, boys and girls, can understand better about the AI, what is computer, etc. So that now this is a new era, and cement plant has to adopt the new change system. The entire human force should be converted into the calibrated engineers. Then it is easy for the cement companies to implement such thing, and which is need of the hour. I hope that the things will improve within may not be 5 years, 6 years, 10 years time, maybe after 10 years or so, and we can see the AI based systems, many plants in India. So thank you very much for wonderful discussions. I wholeheartedly thank and appreciate the answers given by all the panelists from their experiences. Now I will open up, taken up some of the questions. We have around 25 questions. Shall we take now?
I think we are already overshot by 10-20 minutes. I don't think we will be able to take that questions, Dr. Hegde.
Why, Mr. Rao? This is okay, because this is
you can take
running.
1 or 2 questions. You can take. You want me to shortlist?
You can, if you can look at it, and you can read the questions which you feel important, so that because this is
Yes.
a very important session, and it is a value addition to the cement plant people and the listeners.
Okay, so there is one question on. There is one question from Rahul of Helios Technology. Is asking, are there any concerns or challenges in adoption of these technologies? These technologies is referring to AI and IoT technologies. And what are the main barriers you anticipate in implementation? Anybody can answer? Mr. Rizwan, would you like to take it?
Yeah, I will take it. I think the kind of discussions what we're having with the cement manufacturers, right, even in the cement plant, I think there is an adoption, but I think it is not happening at the phase what we are expecting. Like Goyal sub said that one unplanned downtime can take 80 lakh rupees, but I think investing in 10 lakh rupees or 50 lakh rupees worth of AI or the condition monitoring system, online condition monitoring system, is still a question mark, right? Because I think that is also the doubts are coming from the implementation point of view, that whether it will work and how much yield it can give. I think there has to be a validation, there has to be analysis, but I think the acceptability is there, but it not the phase at which it should be, right? If we really wanted to see that we are growing in 5 years, but I think the adoption has to grow. But I think it is also by maybe people would like to see some examples where it's already running, right? I think that is also sometimes it is taken consider that, okay, where is the reference, where is the installation reference, where it is running, right? I think now we have those kind of installation, 1 or 2 plants are coming up, but process optimization is a big time. It is happening now. So it is coming, but it not the phase at which it should be, but I think it will grow.
There is
Very
one
good.
more question. It's about to Mr. Datta. It's about drones are revolutionizing the safety surveillance across industries. How can cement industry utilize drones for ensuring workplace safety and compliance?
Yeah. Basically, see, when you're constructing a cement plant, too many things happen in a huge area. And it's basically a safety manager's nightmare. Equipments are coming in, they're getting unloaded, workers are working at heights. So many things are happening. So basically, even if the mandate is that for every 49 workers, you have to have one safety patroller, that rarely happens. So there are too many people working at the site. At any point of time when you're constructing a cement plant, we work with 1,200 to 1,500 workers, plus the engineers and other people inside the site. And at some point of time during peak moments, the number of workers go even up to 2,000. I've worked with 2,000 workers in one cement plant very recently. So drone is basically a solution there. The first thing that drone can do is basically take care of worker safety and PPE compliance. Drones basically can ensure that workers are using their PPE kits, they're using their helmets, they're using their high visibility vests, gloves, and other PPE equipments. Secondly, one huge area of using drones is basically for site surveillance and monitoring. This real-time aerial views, they can basically ensure that there is no unsafe scaffolding, open trenches, or unauthorized personnel in the restricted zone. We use drones for perimeter surveillance so that unauthorized persons do not enter the area of operation, area of construction. Then drones can be used for inspection of hazardous areas, like drones can go inside the silos where people, the safety patrollers will find it very difficult to reach. Drones can easily go inside those areas like tall silos, chimneys, and conveyor belts. Drones can identify structural weaknesses, cracks, and other construction failures. Drones can basically help us in compliance audit and documentation. High-resolution images and videos can be used for digital records of site progress, and it can also ensure that safety guidelines and environmental regulations are being adhered to.
Okay. Okay.
So
Thank you.
drones have a huge area of
Okay.
application.
Okay, thank you, Mr. Datta, for your excellent reply. I think we need to stop the recording because now we will has a technically we need to stop the webinar. So thank you everybody for your time and excellent interaction during the webinar. And we would like to invite you for our next webinar on 18th of March. And we are grateful to our presenting partner, FL Smith Cement, and gold partner ABP for supporting us. And also we would like to take this opportunity to invite all the participants to our Cement Expo Forum 2025 in Hyderabad. It is starting from March 5th and 6th. So once again, thank you all the panelists, especially our moderator, Dr. Hegde, for taking this, for moderating this session. Thank you.
Thank you very much,
Thank
Mr. Rao.
Thank
you
you,
for the opportunity. And we will be in touch to all my panelists. We will be in touch, and we will continue to integrate the knowledge integration in the days to come. So I wish you all the best.
Thank you.
Please
Thank
take
you.
care.
Thank you
Yeah,
so
sure, we'll
very
be in
much.
touch. Yeah.
Pleasure is ours,
Thank
sir.
you.
Thank you.
Thank you.
Thank you
Namaskar,
very
sir.
much. Namaskar. Namaskar.
Thank you.